Hey there and welcome back to the Code Wrinkles channel for this brand new video. .NET 7 has been released just a short time ago, and the minimal APIs in .NET 6 are, from my point of view, very interesting because there are some nice features added to the .NET 7 version when compared to the .NET 6 minimal API version, and that's why in this video I want to create basically a very short but full course that will introduce you into how to create minimal APIs using clean architecture with repository pattern using Entity Framework Core, with CQRS using MediatR, and also how to perform some very important tasks on the minimal APIs like validation and like global exception handling. So stay tuned because we'll dive right into it. So here we are in a blank Visual Studio 2022 solution in which we will create our entire minimal API application, structuring it into layers according to the clean architecture principles. So let's get started directly with setting up the project structure, what is usually the very first thing that I do for each new project. Now, coming back to this idea of clean architecture, we'll have a very standard way to organizing things here. And the first thing that I would like to do is just add here a class library. And of course, we'll make sure that we choose .NET 7. So the first layer that we want to have is, of course, the domain layer, where we'll store actually our entities. Then create. And it should be created just in a few seconds, probably. It's creating the project right now. And then we should be good to go. Let's just remove this class. I don't really need that. So remove, okay, and here we are. So we have the domain layer. Now let's create another one, and here we'll add a new solution. Here, once again, new project. And in this case, still I want to have a class library, and this one will be our data access layer. So we'll call it data access, still .NET 7, standard term support. That should be okay. So we just create it, and we should be good to go. Also delete this class once again. So I want to really have blank projects. And then the next layer that we need in our application is a new project once again. And this is the layer where we will place all our queries, commands, and handlers, and we'll call this application layer. Now, in terms of clean architecture terminology, this layer would correspond to what is called use cases. So you can call it use cases layer, but in the .NET ecosystem, we usually tend to call it application. So let's create a new class library here. All once again standard, and we'll name this application because that would contain the application layer classes and create. And then we also should be good to go with this one. Let's add here the delete for this class. And last but not least, we need the minimal API because that's the entire scope of this video, or basically a very short full course. So let's add a new project, but in this case, it will be an ASP.NET Core Web API project. And we'll call this just simple minimal API. That's how we'll call that. Let's click on next. Here, one thing that's important when you want to create a project that kind of like is by default a minimal API, you should uncheck this box. So by default, if you have created regular APIs previously, this checkbox will probably be checked. So you have to uncheck it. If you also read what it says here, it's kind of like makes it fairly clear. So unlock or uncheck to use minimal APIs. That's exactly what we want to do. If you want to follow with this video, then also make sure that you uncheck this one so we can then create this solution. And yeah, we basically already have our very first minimal API. So if we take a first look into the minimal API, we see that's actually very straightforward and very similar to Node.js and Express. Like we just have here a web application in which we can register services, then we build the application, and then we map routes, like we map get, and here this is the default in the template with the weather forecast, and then we run the application and everything's okay. Now, what I would like to do is I will simply delete everything because I don't want to be bothered by what we have in the original template. So let's just delete everything. I want also to delete these comments here because we should already know what we need to do in each part of the application. And don't worry, I will guide you step by step and show you everything that you need to know regarding on how to configure your minimal API. And bear in mind that this video is not only about the minimal API, but about how to create a solution, a real solution that you could have as a template for, I don't know, if you start new projects on your own or maybe for your customers. You can basically take this type of organization as your template because we will also concentrate into how to organize, for instance, the code in a minimal API project so that it is readable, that it is maintainable, and also easy to test. So we'll look into all these aspects. But before we'll get started with the minimal API, there is one thing that I always advise people to do. So when you start new projects, when you start on new applications, always start from your domain layer, because that's actually where you model your application itself. I always tell to my mentees that what we do in programming is we try to model use cases or things from real life into a language that computers can understand. In our case, by using classes. So the first thing that we want to do is actually to create this computerized model of the application that we want to build. And then when we have that model ready, then we add to it, like we add the data access layer so that we are able to store to the database and read from the database. Then we add the application layer so that we know exactly what use cases we have, like what we want to do, what actions do we have in our application. And last but not least, we'll also look into how we implement the minimal API itself. The longer part of the video will be dedicated, of course, to the minimal API. But before we get to the minimal API itself, let's set up, first of all, our domain project. So let's start, as said, with the domain layer. And here, first of all, we will add a new folder and we'll call this folder models. You can also call it entities, call it whatever you want. The idea is that here is actually where we put our domain model or our core entities. What we will try to build here right now is a very, very basic simulation of a social network like Facebook, where users are able to create a post. So that's why we will add here this class. And we'll call this class as a post, because that's what we want to actually model in our application right now. And this will actually be a very, very simple post. Here we will make this public because we will need to use this class also in the other layers. And I have already prepared here are some properties of this post. As said, it will be a very, very simple entity. We don't want to concentrate on all the domain stuff. If we want to have, well, a better understanding on how to model the domain, I have plenty of videos on this channel, on this topic, like what's a rich domain model, what's an anemic domain model, how to structure models, and things similar to that. So we have already covered those topics. Now we just want to have something to get started with it very, very quickly, and that's basically our post. It has an ID. Then we have a string which contains the content or the post content, and yeah, let's make it even nullable. And we have a date time, which is the date created, and the date time, which is the last modified. Those properties kind of will never be updated by clients or by consumers. They will always be updated by our application itself, because there we know exactly when we need to set the created date time and when we need to set the last updated date time. So that's actually what we will do and what we will handle in our repositories. And this being said, actually, we are already done with the domain layer. We already have the entity or the core domain model that we need for our application right now. So we can just move over to the next layer that we would need. And this is actually our data access layer. Now, in the data access layer, the first thing that we need to do here is we need to install some NuGet packages. So let's do that. And the NuGet packages that we need here is, first of all, Microsoft Entity Framework Core. So let's search after it, because that's what we need to install here. Now, the things that we need here is Microsoft Entity Framework Core, like the core library, and make sure that it's also on version 7, because we are on .NET 7 here right now. So we have to keep those two in sync if we want everything to run correctly. And then we'll also need the SQL Server from Entity Framework Core, because that's kind of like what we will use underneath. And we'll have a database in SQL Server Express. It kind of like ships with Visual Studio. And yeah, I guess for the data access layer right now, we should be good to go. So the first thing that we can create here in the data access layer is, of course, a class for our data context. And let's call this class that we have here social DB context, because it will be a social media application. So we'll call it social DB context. We also need to make this public, because we'll need to add the DB context also to the DI container. And this means that we have to access it also from another layer. So we need it as public. Now, to make it as a DB context, we just have to kind of like inherit from DB context. But for this, I also need to spell it correctly. But yeah, this is done. Now we need a constructor because we'll use this social DB context with dependency injection, and we have to pass in DB context options that contain our connection string actually. So we'll have here DB context options, and we'll have to pass those options, of course, to our base class, which is in this case our DB context. So we pass in the options, and that should be it. Now, the next step that we would need to do to set up a DB context is, of course, we need to work with this entity, which is post. We'll have public, and we'll have here a DB set of post. Here we'll need also probably a reference to the domain project and have a using statement here and have add reference. Now we should be good to go, and we'll call this posts, but also let's type it correctly. And that's a property, so get set. And yeah, that's more or less our DB context that we would need. Now, the next thing that we would have to think about in the data access layer is that we kind of like need to create the repositories. But in order to have repositories, what we would need to do is, well, actually we want to have an interface as said, but where do we place this interface? That's a good question. And the answer is, by the way, there's also a video on the dependency inversion principle on the Code Wrinkles channel that will explain, or that already explains this in very detailed way. But the main idea or the core concept here is that the interface should always be owned and defined by the client. Client meaning that layer or the package that actually consumes it or that needs that functionality. So in this case, where will we need the functionality of repositories? What layer will actually work with the repositories to get some data and do something then with the data? Of course, it will be the application layer. So in this case, we'll also go to the application layer. Here we'll add a new folder, and this folder we'll call abstractions. Let's make sure that I also spell it correctly. I guess it should be fine. And here we'll add a new class, and we'll choose to be an interface, and we'll call this posts repository, something like this. But maybe, yeah, let's just use the singular form, so post repository, because it is a repository for our post entity. But once again, I have to also type it correctly. Now it seems to be fine. And also we'll need to make this interface, of course, public, because we will actually need this interface in a total different layer. And what I have already prepared so that I really don't have to write a lot of code here that we don't need is kind of like all the things that we need to implement here. First of all, of course, we will need to add a reference to the domain because the post is there. And now we should be good to go. So it's a very standard repository with all the CRUD operations that we want to implement also in our minimal API, of course. We have this get post with comments. Okay, actually that one we will not have because we will not have comments. We'll have here get posts, or let's call this get all posts. Something like this. And also, yeah, we don't have this concept of comments here right now. So get a post by ID. So int post ID, cool, then create post, update post, and delete post. And we should be good to go with the interface definition for the repository. And the implementation, of course, of the repository will have in our data access layer. So let's go back to this layer and create a new folder here. And the folder we'll call repositories, and in this folder we'll create a new class, add new class, and we will call this class, of course, a post repository. We will need to also make this public because we'll need this in the application layer actually, even though in the application layer we actually just use the interface, but we need it for dependency injection in the minimal API, and this would implement post repository. So that's what we implement here. And of course, here we'll need to add a reference to our project, add a reference to application. That's exactly what we want. And then we can even just wait a little bit. So VS 2022, this version 17.4 is actually very, very, very slow. And I don't exactly understand why, but virtually that's our repository that we have right now. Cool. Now, I also have here prepared some things that we want to actually implement. So the first thing that we want to implement is this create post. But before we get started with the implementation of these methods, we have to make sure, for instance, that we'll have here a private read-only social DB context, because that's our DB context that we want to use, and we'll call this CTX. And of course, we will also need a construction for this. And in the constructor, we want to have social DB context, and then we just need to assign this here like this, and we are good to go. So now we are set up. It means that when we will wire everything up with DI, it means that each time that we actually need an instance of this post repository, an instance of the social DB context will be injected in our repository. So this means in turn that we can now concentrate on creating or implementing this type of methods. We have here this async task create post. So what we do here, or what we need to do here is, well, just to create the post. Okay. Let me just did I name this? Let me check here. Yeah, we need to name these posts, because that should also be the name of the table in the SQL database. So right now we should be good to go with this. So the logic for create post is very, very simple. We get a post here that needs to be created. We get it as a parameter to the method. Then we manually set the date created. So that's the place where we can define, okay, when do we need to actually update the date created and the last modified. So we just do that. The post content should already be there. So we just add this post to the post, and then we await and save the changes. And we return the post that was actually created, because by the time it gets created in the database, this post will also get an ID. We have to return it so that the consumers or the callers of this method would know exactly what ID was generated for the new post that was added to the database. So it's very, very important that we return this created post to our consumers, or to whoever actually wants to use this method. And then the next one that we need to do is we need to implement a delete post. And I have also prepared a code snippet for that. We'll walk through it, of course, but it would take really, really longer in order to, implement it from scratch. Now, the only thing is that we need to make this method async. And yeah, here we don't want to include the comments, because we don't have this functionality right now in this application. And yeah, first or default async. So yeah, the idea is that we kind of like don't need to do this, but here we'll have to change, because from post, actually what we want to do is, if we get the post, so this is first or default. If post is null, we return null, because we cannot delete it. But if everything is okay, then we say context.posts.remove, and then we can just specify the post that we just got from the database and say that this needs to be removed, and then we await the saved changes, and then everything will be deleted, and that would actually be okay. Now, the next thing that we need to implement is the get post. The get post, like the list of posts, is very, very easy to implement, because here we can just also, of course, we need to make this method async first. So it's async task of a collection of posts, and then we return ctx.posts, and we can just say that here, to list async. We just want to return it like that. Now, eventually, if we don't really want return await, of course, ctx post to list async. If we want to not return the list directly, we can, define in the interface that we return an enumerable here. And then in that case, we can just return the post DB set, and that would also do the work. The difference is here that when we use the toList async, EF core actually buffers the data, so it loads it into memory. When we use the iEnumerables or the iQueryable, so just the ctx.posts, then it actually streams the data, so it's not loaded everything into memory. So keep this in mind when you're thinking about how to optimizing your queries. That might be very, very important. Now, the next thing is, of course, that what we want is to get a post by ID. That should also be very, very easy to achieve, because we can just return await ctx.post, and here first or default async. So that's what we kind of like need to do. And here we are searching for a post that has the ID equals to the post ID that we get here as a method. So yeah, let me just do this here. Of course, there is here a slight warning here, because this can return null, and we haven't turned off the nullable reference type feature. So this is why we have kind of like this green squiggly line, but it really doesn't bother it, or it really doesn't bother me too much right now. And then the last thing that we need to implement here is this update post method in the repository. So we have updated this one. What we do here, of course, like we get a string which contains the updated comment, and we get an int for the post ID. So what we do here in this case, well, we look for the post, of course, but then we just don't need to include the comments once again. So that code snippet is not actually what we want. Of course, we need to also make this method async, and now everything should be okay. So now what we do is we get a post from the database. That's okay. Now, if we have this post, then we set the last modified date, because we update the post. So we need also to change that property. And then what we have here is updated content. Like that's what we want to update for the post. And then we await the save changes. And then we return the updated post. And that's it. We have actually right now implemented our repository. Now we can even make things a little bit cleaner, just remove the things that we don't need here, like these ones. So we keep everything as clean as possible. So I think that we might right now be good to go with the next step of implementing our application. And the next step that I would like to do is I would like to finalize kind of like this creation of the data access layer by adding Entity Framework to our minimal API project, because we need that in order to be able to run a migration and to update the database. So this is what we'll do actually as a next step. To do this, we need to head over once again to the minimal API project, where we have everything set up. And by the way, guys, I already have a database created, and I have already added the connection string here as my default property for the local DB where my database is created, which is this minimal API course. So this is already my database. It's a blank database, so there is nothing in it so far. And what I want to do is, well, we want to test actually that our migrations work with for the data access layer, and that we are able to update the database. And to do this, well, we have here regular stuff. Like we want to add different things here, but of course we need to add some NuGet packages for that. It's like standard way of adding the DB context and repositories to your service collection in a regular .NET 7 application. So even if you have regular API with controllers, you would do this exactly the same way. So there is no real difference when it comes to services registration. It works exactly the same. Now, what we need to do, of course, here is we'll need to install some NuGet packages as well. So let's go here to NuGet packages. Now, the packages that we need here, because what we want to do is we want to add migrations and update the database. And to achieve that, we'll actually need some more packages compared to what we had, let's say Microsoft Entity Framework Core, what we have in the data access layer. So first of all, we would need the regular ASP.NET Core Not Identity. Why is it? Okay, sorry, I have chosen here something wrong. And Microsoft Entity Framework Core, that's what we actually want to have here. And yeah, we need to add this package. Once again, we make sure that it's version 7 because it's the .NET 7 minimal API, so we have to be consistent. That's the first package that we needed. And the second package that we need is, of course, the SQL Server package, because we are using SQL Server and it's still very, very slow, Visual Studio. Sorry for that. So let's also install that package. And there is one other thing that we need. We need the tools, because this is the package that's kind of like used in order to be able to add the migrations, update database, and things like that. So let's also install this package. And then from the Entity Framework core perspective, we should be good to go. So, okay, all packages are ready. Let me close this one. And here, of course, we'll probably need to add some usings. Here, we also need a reference to our data access layer. So add the reference to data access, because that's the layer where we have our social DB context. Use SQL Server. This comes from Microsoft Entity Framework Core, so we will use it like that. And then the iRepository, that comes from the application layer, and here using application abstraction, so that should be okay. And then, last but not least, the post repository, that also using data access repositories. And in that case, we should be actually good to go. So right now we should be set up. So let's head over to the package manager console, which is this one. And what we need to do is, because we have, let's say, the project that kind of like is the entry point to the application is our minimal API, but the project where we want our migrations to be is the data access project. So in this case, we set here the default project to the data access project. Now let's say here, add the migrations initial. Okay, and we have a problem. Add the migration, sorry, without S. So that should be good to go. So right now it's building. Hopefully it builds okay. Hopefully we don't have any build errors, and hopefully that the migration will be created very, very soon and everything will be okay. Build was successful, so that's the first very important thing. Okay, one other thing that we need to do for the solution, and by the way, that's important. So we go to the solution properties, and we need to set the startup project, because by default it was set to the first project that we have added to our solution. So we have to change this to the minimal API. And since we are here, there is another thing that I would like to do on the CS profile. Like if we right click the minimal API project and then go to properties, there is one thing that I would like to do when this page loads. Of course, I want to go here to debug, and here we need to open debug launch profile, because this is what we need. What I want to do is I want to get really rid of this idea of launching the browser when we start the application. I don't really want to launch the browser. I want to have or to use Postman in order to be able to actually test the functionalities of this minimal API. So that's what we actually have done here. So everything should be prepared right now. Let's give it another try then. So add migration initial. Now the build was succeeded. It was faster than the first time. And yeah, we see that here we got actually an initial migration to this. And let me check if there are any problems with this file, but hopefully not. No, everything seems to be fine. And then it just creates the table with the posts with everything that we have defined. So nothing really complicated there. So then the next thing that we would like to do is update database. So build started, it builds again, it should also be successful, and indeed it was successful. And we can see that, it has executed correctly. We have created a table, so create table with all the stuff. So it means that the table is right now in the database. So this means that we are good to go from the point of view of the data access layer. Now, there is a last layer that we have to take care about before we move to only the minimal API stuff, and that's the real application layer. And as said, we want to actually use MediatR for that. So it means that we will have to set up MediatR. Now, the idea is that the queries and the commands and the handlers for them will all be in this application layer. So it means that what we need to do here is we'll go to manage NuGet packages, and we will need to look for the MediatR package. However, here there is one thing that we need to always, it's not Microsoft, is MediatR. Jimmy Bogart's library, very popular library. So yeah, we have here the mediator. Now here we have to pay attention to one thing. Like we have here two different libraries, or two different packages here, or NuGet packages. One is mediator, which is the core mediator functionality, and the other one is mediator extensions Microsoft dependency injection. So this is a package that contains extension methods that allows us to register the mediator with the DI container. Now, in the application layer itself, we just implement the core, let's say, CQRS logic, like we have commons, we have queries and handlers. So we don't really do anything with DI there. We just create our commons and queries. So in this case, we would need here in this assembly only the mediator, so the core library of the mediator. However, and that's the very important part, as we want to add our mediator or the mediator to our DI container, there is one other thing that we need to do, and is let's go also to the minimal API layer or project and also manage NuGet packages here. And we will also need to install mediator here, because here is the place where we actually want to register the mediator with dependency injection. And therefore, of course, we need this package here, like mediator extensions dependency injection, because that's what we want to do. However, it's important to note that when you install this package, the core mediator package will also be installed with it. So yeah, that's kind of like the reasons why we just need this one, because we need actually the extensions for adding mediator to DI or to the dependency injection container. Cool. So we have added this. Now the last thing that we will need to do probably here is to also make sure that we would be able to kind of like also add mediator to DI. But in order to do that, let's first of all create a few commons here, because that's actually or queries and the handlers, because that's actually the important part that we want to do. So yeah, let's head over to the application layer. And the way that I like to structure an application layer is that I want for each type of functionality to have a dedicated folder in which I will place then all the queries, the commons, and the handlers, and if I need anything else for that specific feature. So that's why the first thing that I'll do here is add a new folder, and I'll call this folder posts, because that's the post functionality. We will have all the commons and the queries and the handlers for this post functionality. So this means that here I will have also some or a bunch of subfolders, which would be the queries. First of all, then we'll add a new subfolder, and this other subfolder will be, let's call it commons. Then what we will actually need for the handlers, I guess we'll create dedicated handler folders. So sorry, in the posts here we'll add a folder for command handlers like this, and we'll also add a folder for the query handlers. So add a new folder, and we'll call this query handlers. Okay, cool. So let's start with the command, because in order to get the post, we just need to create one first. So let's start with a new command, and that would be add new class. And in this class, and we'll call this just create post, because it's clear from the naming, it's create post. It's a command. We want to do something. We want to actually change the state of the application. Now, of course, we will also need to make this class public. So it will be public. Now, what we will do here is we will inherit the I request, which is the interface from mediator that kind of like describes what a request is. And this is a generic method, or this is a generic interface where we have to specify a generic type parameter pointing to what we want to return from this command, and we want to return a post. That's why it is an I request of post. Now, when we create a post, if we have looked a little bit at our data model, is actually we have the ID which is generated by the database, we have the date created and last updated that are always handled by the repository. So the only thing that we actually need to do or to use, or the only thing that we need in the command is actually a string that represents the post content. So it would be public string, and let's call this post content. And yeah, it's a regular property. We can even make it nullable to make it clear anybody that this might be null. However, we will implement later validation and we'll make sure that this will not be null actually, and then we can clear everything up. We don't need this stuff anymore, so let's just click that. Cool. So now we have this one with create post, and then we need a handler for that. So let's add here a handler, and we have a class here, and here we'll call this create post handler. And the handler, so in MediatR, to implement the handler for a certain request, well, first of all, we will make this also public. And here we need to implement the iRequest handler interface, also coming from MediatR. And that's also actually a generic interface. And we have to specify two type parameters. The first one is the command for which this handler will handle the request. And then the return type. What will it return? And we will return post. Okay, here, of course, what we'll need to do is we'll need also a using for the domain, and then we also need to implement the interface, and yeah, that would be it. Now, the first thing we will need to do here is we'll need to make this async, first of all, because it will be async. And then, obviously, what we'll need into a handler is always the repository, because we use the repository to perform stuff. So we'll have a field here, private read-only field, that would be of type I post repository, and yeah, let's call this I don't know how we should call this posts repo. Let's call it like this to be clear what we actually want with that. And then we can have the constructor, and in the constructor we just want to inject the repository because we already I post repository, and let's call this post repo like that. And then if we go here, basically we can already do the stuff that we need. So assign what we get from the DI to our private field, and that would be it. Now for the handler of this one, let's use some code that I have already prepared. Just give me 1 second. Here it is. So of course we don't want to throw a not implemented exception. That is always bad, and the sign that we are not using the interfaces the right way. So what we do here is actually we create a new post, and for the new post we actually, well, we add this date created or the last modified. However, thing is, what I would like to do is actually we should remove this from here, and the new post that we need to create should contain only the post content, and we have, or we'll head back to the post repository, and for the create post, because we already set these dates here, so we have done this correctly. But then in this handler, we don't need those dates because they are set by the repository. So in this case, we are actually good to go. We just await post repo, create post, and yeah, we provide a new post, and then the post will be created, which is very, very nice. Cool. Let's now implement all the other commands that we need for a full CRUD. And those other commands are, for instance, the next one would be the update post. So let's have here one, and we'll call this update post because it's clearly what it is about. Cool. So what we'll do here is let's make it public first of all. So that's a very important thing here. And once again, we need to inherit this iRequest and to specify what we exactly want to return. And we want to return an updated post. Of course, that's also what we would need to using domain models. Now, the thing that we need here is to update a post. First of all, we need to identify which post we want to update. So we will need an integer, not a post, public int post ID. So this is the first thing that we would need in this command. And then what we'll need, of course, is the updated text or the updated content of the post. So we'll have here public string post content get set, and we should be good to go with this command right now. Okay, cool. Let's just remove this stuff that we don't need. So we can close this, and then we can create a handler for this. So let's go here and create a new class. And this new class should be update post handler. And of course, we'll also make this public, even though we need at least one that needs to be public. Theoretically, all the others could be internal. However, we'll keep consistent, and yeah, we'll have those public. So I request handler. That's what we need to implement. Once again, this is a generic interface, and we have to specify two generic type params. The first one is actually what we want to, what exact command or request this handler should handle, as the name implies. And that would be the update post, and what it will return, which is an instance of the updated post. So we also need a reference here to the domain. And yeah, we have that right now. And then we need to also implement the interface. Now, of course, what we would need here is, once again, we can take it from here. So we need this private field, because it just needs to contain this this repository for the posts. And what we'll also need here is a constructor. And in the constructor, we just need to have the I posts repository, posts repo, like that. And then, of course, here we can just, well, add what we need, posts repo equals post repo. I wonder why Visual Studio didn't really gave me the suggestion to just complete that already, because yeah, that's how it should actually work. Now here the logic for this will be also very, very easy, because we have the repository that does all the stuff. The only thing that we want to do is here, yeah, of course we need to make this async also. So yeah, done. So we have fixed this. Then we just, well, use this post repo update post. We provide the content and the post ID, and then the post should be updated, and we are once again good to go with this command. Now there is one final command that we need to implement, and this would be the delete post command. And the delete post, let's, as said, keep consistent, and we'll have public class delete post, and that would be an I request. And here in this case, we don't return anything. So it means that for the delete command, we will not return anything. So we'll just have this I request. Of course, we will need to add a reference to MediatR to do that. And the only information that we would need in this command is the ID of the post that we need to delete. Public int post ID, something like that. And we should be actually good to go with this one. Now I have a problem here. What's the problem here? Okay, because it's post repo, so it should be okay right now. Cool. Let's go back to this update command, because not update, delete. We were working on a delete, so the delete command is actually ready. Just remove the unneeded stuff here, and then we just need the handler for that. So add a new class, and in this case we'll have this delete post handler, and yeah, we'll also keep it consistent, public class delete post handler, and that would be an I request handler of delete post, because here we just have to specify what we want to do, or what this class should actually handle. Then we need to implement the interface. Now the only thing that we need is, once again, we need here this repository, so we will take it from there. Let's just make here just a bunch of space. So we add this one. Let's add the constructor, and in the constructor we'll add the I post repository posts repo, that, and then let's just assign everything, and we should be good to go with this one. Now the only thing that we need to do here is, of course, make this async, because it will be async. Now MediatR, when you don't return anything, it actually just returns a unit. The unit is just a struct that represents a void type, because you cannot return void from tasks. And this is how MediatR has decided to actually handle this type of scenario. Now for the delete itself, like the handler, it's really also, once again, nothing very, very complicated. The only thing that we need to do is just use the repository and delete the post. Here, of course, we just need to make this correct, and then return unit.value, which is actually the unit. Cool. So it seems that we still have an error somewhere. I'm not sure exactly why. Update post. Reason for update content. Okay. I guess we call this post content. Okay. So yeah, now we should be good to go. Now we shouldn't have any errors. So we have all the comments implemented right now. So then we have the next thing is we have the queries. And after just a few more classes, we are ready to actually head over, fully concentrating to the minimal API. Let's get all posts. So this is the first query that we need. And yeah, we'll make this also public. And then this will be an I request, and what it will return, this I request, will be actually an I collection, because it will be probably a list. Sorry for that. So it would be an I collection of posts. Probably will need to add some using here. Of course, using the domain. Now, for this get all, we actually don't need any information right now, so we don't actually need to populate the class with anything. Now, this means that what we can do here is we can head over to the query handlers and add here a new class, and we'll call this class get all posts handler. So it should be something like that. Well, that would be a public class get all posts handler, and this would be an I request handler of. First of all, we need to specify the query. So get all posts. This is the query, and I will specify what it should return. It should return an I collection of posts. So that's actually what our handler needs to do. Now, there are a few things that we need probably to add as using here, the domain models. And then we'll also actually, okay, but here VS is also playing crazy, because theoretically that it should give me the option to kind of like implement this interface. But yeah, in that case, it just doesn't do that. So yeah, let's maybe just do this here, get all posts handler. So let's open this again. And yeah, in this case, now it works. So the perks of using Visual Studio, and these things happen. So let's have this async. Now, the one thing that we need here that we can copy over from the handler is, of course, the field that contains our repository. So let's just move it here. And yeah, let's use it. That's the repository. Let's add the constructor to that. In the constructor, we need I posts repository, and let's call this posts repo. And then we can just assign it here. So it would be posts repo, and it should be like that. However, I always like to have here a space between those two, so I will just add that. Now, for this one, for the get all posts, which is the handler for this, actually, it's also very easy to implement, because what we need to do here is just return await posts repo dot get all posts. That's kind of like what we need to do. And yeah, we should be good to go with that. And the last query and the handler that we need, and then we'll head over to the minimal API. It's a query for get post by ID, get post by ID. So that's actually it. Let's once again keep it consistent. Let's make this public. Then get post by ID, and this would be an I request, and this request will return the post that we actually want. So let's also make sure that we need this domain model. Now, the next thing that we need to do here is, if we want to get a post by ID, of course, we need to identify that post by the ID. So that's why we'll have a public int post ID. I want to make it explicit, so I know that it's the post ID, not just ID as a general ID. So it's the ID of the post, and therefore I prefer to kind of like name this property like this. So that would be the request. Just let's remove the stuff here, so we don't need it anymore. And then the query handler for this one, and that would be here, add new class, get post by ID handler. That would be the class name. Once again, let's make it public first. Then let's inherit I request handler. And once again, get post by ID is the query that we want. And what we will return is just a post. So in this case, it means that first of all, we will need to add the using for our domain. And second of all, we will need to just implement kind of like this. Well, get all posts. Let's just keep this. Let's maybe just copy over everything from here and just change the name that we actually use there, because that kind of like, it's the only thing that's kind of like different. So instead of get all posts handler is get post by ID handler, get post by ID handler. So now we should be good to go. And of course, the only thing that we need to do here is we can just go here and say return await. Of course, we need to set the async keyword then here. And yeah, we have made this as an async method. So post repo dot get post by ID. Where is it? Get post by ID. It's this one. And we just need to provide the ID, which is the request dot post ID. That's what we have. And yeah, we are right now ready with our application layer. So let's maybe just, I don't know, rebuild the entire solution to make sure that everything works. Now, before we head over and concentrate only on the minimal API itself, there is one last thing that we need to do. We have to wire up the mediator and the command handlers and the commands and the query handlers. We need them to be wired up in dependency injection container. So this is why the first thing that we need to do here is we should go here to the minimal API. Here we have this program.cs class. And in this program.cs class, what we need to do is kind of like just add, for instance, what do we need to do? Builder services at scoped, and yeah, add mediator. And here we have this create post, but we did name it just create post. So that that should actually do that for us right now. So we have this create post, application post comments, and yeah, that's where we have everything. So right now, what we have done is we have added the mediator with everything that we actually needed. Cool. So the next obvious step is that we have to start actually build out our minimal API and then create the endpoints, and that's exactly what we will do next. The first endpoints that we will create are the endpoints for retrieving a post by its ID and the endpoint to create a post. And the reason for that is because obviously we need to add posts in our database so that we can use all the other endpoints. But then again, the other part is that when we want to create a post, we need to return a 201 created result that will also contain a location header with the exact resource or the exact URL where clients might be able to retrieve the newly created resource. So in that case, we need to first implement this get by ID and then the create post. So let's get just right into that. So first of all, we have this app. After we build it, we have a web application. Now, my idea is that it would be probably best to add or to map all your endpoints actually just before the app.run part, because here the other part you should reserve for registering middleware. Middleware actually work exactly like they work also in regular ASP.NET Core APIs with controllers. And in fact, at the end, we'll also look into a very useful middleware that we will implement here in our minimal API application. But let's get started. So the first thing we suggested is that we should have here this map get, because we want to have a get, and that's how you map a get endpoint. Now, when you map an endpoint in a minimal API, there's actually two things that you need to provide. First of all, you need to provide the exact location where this endpoint or the route for this specific endpoint. So in our case, it would be API/posts, and since it will be a get by ID, we have to also specify the ID as a routing parameter. So just like we do on the route attributes in regular controllers. Now, the other thing that we would need to provide is, of course, the handler. So when we have a request for this specific route, somebody should handle that. Like the way that we have command handlers and query handlers in our application layer, it's exactly the same concept. We have here a route, and for that route, we need a route handler. Now, a route handler in a minimal API is virtually a method. Now, when we talk about this type of methods, there are some different ways that you can use them. Now, the first and the most obvious thing that you could do is just use a lambda expression. And that's what we will do in this case, because a lambda expression is nothing else, actually, than an unnamed method or an anonymous method. So we can just use it here as a route handler. Now, there are some things here. So first of all, we want to have this as an async method. And secondly, we need actually to bind, for instance, this parameter that we have in the URL. We need to get it somehow in our route handler. The thing is that it is really similar to how things work with regular controllers, because the only thing that you would need to do is actually here just specify an int ID. Like, we should make sure that kind of like this matches this, so this should be an exact match. And then basically .NET 7, when we'll have a request with this route, it will map the number that will come here. It will map it and place it as a parameter in our method. That is how these things work. Now, the second thing that we have to think about is how do we get our mediator here? Because in controllers, we usually inject them in the constructor of the controller, and then we can use them. However, constructor injection, of course, is not available in .NET 7 because we just use here some methods that we defined that they are actually the handlers for a specific route. In this case, we cannot simply use constructor injection, but we can use method injection. And of course, it works exactly the same like the constructor injection in regular APIs. The only difference being that, of course, we need to specify what we need to inject also in as a parameter for this method. So we'll have mediator. We have also to type it correctly, and then we have to also define them or separate them by a comma. And here, of course, we'll need to add, okay, but I don't want the mass transit. So yeah, I guess I have named that wrong. mediator, yeah, now it works. So everything is okay right now. So what we have done is, once again, when you think about dependency injection in minimal APIs, you always inject in the constructor, or no, not in the constructor, but in the method. So we have method injection. We don't have constructor injection here. But other than this, it works exactly the same. It's the same dependency injection container, and it will provide you all the information or the registered services right here when you need them. Now, the one thing that we need to do, of course, is when we have this kind of like method, what we need to do is, okay, we need to implement the logic. What should happen here when this method gets executed? So when we have a request for this route. And the answer to this is actually very, very easy, because the only thing that we need to do is we just need to create a query. And from that query, we need to send it to the mediator. So let's have here, for instance, for this var, we get a post, get a post equals new get post by ID. And then in this get post by ID, we have the post ID equals ID. So it's exactly the same that we have here. Now, what we need to do here is, this is actually the query. Then we need to get the post, var post, and this equals to await mediator dot not publish, because we don't want to publish a notification, but instead we want to send a query. And yeah, we'll send them the get post, of course. So that's what we do. Cool. So we are good with that. Now, the only thing that we need to do when everything is done, we need to return something. So what we'll do here is return. And here is, in the minimal API, we have this results class. And this works, actually, you can imagine this class as being something similar to what we have, or to what the iAction result is. So it has basically more or less the exact same methods that we can use. So if we want to return OK, we just return OK, and then we specify, OK, what would be the body that we want to do or to add. However, there is one important thing that we need to do here. And when we create such endpoints in a minimal API, we can actually add to them a lot of information. Like, that would be called the endpoint metadata. It's called like that even in the .NET 7 minimal API documentation. And that metadata is important in certain scenarios. Now, in our scenario, why the metadata is important is because when we create a post, we want to be able to return a created result and to also very easily specify a location header for where exactly that newly created resource can be accessed. And in order to do that, from the create handler, we have to reference in a certain way this map get for the post by ID handler, so that it knows, so that .NET 7 knows exactly how to build kind of like that API and to place it in the in the location header. And to do that, the easiest way to achieve that is actually to have to use this with name information. And here we can call this, for instance, get post by ID. We have specified this metadata information. Now, this means that what we can do now is we can come here and say app.map.get, not get, but it's post in this case, to map a post, because this is where we want to create a new post. So first of all, once again, we need to provide the route, and that would be, once again, API/posts. It would be the same. And then we kind of like need to provide the handler for this, and we'll provide it also as a lambda expression here. Now, also this one will be an async. And then what we'll need here is we'll need also a post from the body, but we'll also need the iMediator. We need it virtually everywhere. So we have the mediator, and then we have the post from the body. And it works exactly the same like in a regular controller. So like if you say here that I want a post, it will look into the body and check if you have a post there, and or it will take the data that it finds there and will try to map it to a body. Now, this all will or would also happen by default, but if you want, you can even specify here exactly with this attribute from body, like specifically look in the body. So we want to be very precise and very exact, and in this case, we can specify that. However, there is no need to really do that because .NET 7 will know exactly how to look and bind your parameters. Some of them will be injected from the DI container, and this one, for instance, will be taken from the body. So in this case, we are actually good to go with this one. Now, what we need to do here is, well, we can just create the post, and here I have the code snippet for that. So we have a create post, and we have this create post, which is the command, but we just have to remove that. Then post content is equal to post content. So it's exactly, the content that we get from the body. Then the created post, we await and send it to the mediator that will return us the body. And here is how we then return the 201 created result. We also use this results class that's, as said, is actually kind of like the replacement for iActionResult that we have in the controllers. Here we call this results. There are also other options, and I will show you the other options just a little bit later, because we really need to be aware of that other options and what pros it actually brings to the table, because it's very important. But for now, let's get accustomed and concentrate on these results. So we return then created at the route. And then what we have to specify here is the name of the route. And that's why we have specified here with name get post by ID. And in this case, we have to make sure that it's exactly the same, because otherwise the naming will not match, and .NET 7 will not be able to construct the location header. Then similarly to what to when we create a created result in a regular controller, we need to provide an object that will contain the parameters or the routing parameters, like we need the parameter for the ID. So that's what we provide here. And then once again, the body for this. And this is how we return this created result. So we should be good to go with this one. Now, let's also maybe implement the other methods. So app.map.get. So we want to implement this get all. So let's just think a little bit about that. First of all, we need to provide the route. So it would be, once again, /API /posts. But then it is by ID. So I guess we should be good to go. So async. And we'll also use this lambda expression once again. And later I will show you how we could do this differently, actually. Cool. And then what we have is that get all posts. So yeah, that's also something that we can have here. Like get command, get all posts, and then we have the mediator. Of course, we need the mediator. We need to inject it. Mediator. So it's this one. And yeah, then we can just send everything and then we return. And this is the typed results. But let's change this to results right now. And we'll go back to what a typed result is just in a few minutes. So this would be the get. Now, the only thing that we need to still implement is, or are actually, the app.map put for the update. Now, for the update, what we'll have here in the route is, first of all, yeah, /API, but I have to hit also the correct keys on my keyboard, API/posts. And then we also need the ID, because yeah, we need the ID of the post that we want to create. Now, let's just also add the lambda here, so async, and we'll then just populate it with what we actually need. And here there is one other point that we have to be a little bit careful about. So we will need a mediator. We see that we need a mediator basically everywhere. So let's add the mediator. So it's this one first. But then here there are a bunch of different other things that we need to map. So we will need to also map from the ID or the ID of the post, and we also have to map from the body from where we actually receive the updated content. Now, what I would like to do, and we'll see a little bit later why this is important, the other endpoint where we actually get a post from the body is this create. And I would always suggest you, when you have this type of situations where you kind of like have something that you get from the body and you want to map it to your own type that you will use then with the repositories, make sure that in all the methods or in all the route handlers where you actually need that, to place them at the exact same order that they were placed previously. So previously, this post was actually placed as the second parameter here. So we'll have to make sure that is also the second parameter here. So it's a post, and then we'll have this ID int ID, which would be the routing parameter. And we'll see just in a few minutes why this detail is actually very, very important when we will talk about validation. Cool. So right now what we want to do is just update this post. So what we'll do here is we'll just use the code snippet that we already have. Now here the command in our case is just updated post. So it's just what we had previously, like we have the ID. I guess this one we have called post content here. So we could change that, and yeah, we right now should be good to go. Updated post, await, mediator, send, and after we get the result back, we return a result okay and this updated post, which is actually very, very nice. And the last method that we want to implement, or the last route, or the last endpoint, app.map delete, because that's actually what we want to do here. Now, as we have seen previously, what we need for the delete here is actually just the ID. So we'll have /API /post/ and we need this as a routing parameter. So we'll place this then in angle brackets in braces, but it should be called ID to be sure that everything is consistent. Then let's use the lambda here for this delete. Now, the only thing that we need to, once again here, is the iMediator. So let's just use this mediator. And we also need the routing parameter. That would be an int, and it would be the ID. And now for this result, I will just take it and then also use the code snippet that we have here. So it is the delete post. And then I guess we should be good to go. So we create a command for that. We use the mediator, we send this, and then we return this result no content. So that's it. We have implemented endpoints for all the CRUD operations on these post resources. Now I have also opened and prepared Postman with a collection of requests for this minimal API. So let's see if things are working well. Let's run the application first, and then well, it maybe will take just a bunch of seconds until it gets created, and well, everything should be fine, I guess, right now. So we can just go here. So as you see, I have this minimal API course, and I have here a collection of requests. here is, for instance, to create a new request. So we have a post to the local host where we have this application running, API and posts, and the content for this post would be my first post. Although I guess there might be a slight problem here. So let me just stop this and let me just check again, because here is post and the content, and let me check the post here. It's still running. Why is it still running? I don't want it to be still running. Cool. So yeah, let me look a little bit into the post that we have here. So it's content. It's cool. We are good with that. And here it's also content. So yeah, we should be good to go. I was thinking that maybe I had different property namings. So that was my fear. I had to double check that. Let's run this again right now. And yeah, try it out. So first of all, we want to create a new post. So we have to send the request. We just wait a little bit, and hopefully we get a right response to our request. It goes to the database. The first time is a little bit slower, but we see that we get a post back. And if we look into the headers here, where are the headers? Here are the headers. We see that we have this location, and they say that we need to be able to retrieve this post in the location that's API post and the ID 1. Let's try it out. Let's go to this endpoint, API posts. Let's change this ID to be a 1 because this is what I want to get. And this time, I guess it should be a little bit more quicker. And indeed, so we did get everything that we wanted. Let me just to play around, add another post, my second post, and yeah, send it. And I have created that. So if we go to the get all posts, I guess we should be also able to retrieve the entire list. So indeed, we have 3 of them right now. Let's also create a third one. So we had 2 of them. So let's create also a third one for my third post. And this third post has the ID 3. Now let's update something. So we want to update the post with the ID 3. And here I have here my first updated, let's say my third updated post, because it's the third post that I want to update. So let's click send, and we see that it was updated. So if we get all posts once again, the third post is my third updated post. So it was correct. And now we can delete it, and we want to delete the post that we just have updated. So let's delete, send, return 204 no content. So it seems to be right. Now, if we go here and we run this, we see that the third post was deleted. So indeed, we just have 2 posts right now in our database. So everything seems to be working okay. Cool. That's really, really great. But even though most of the tutorials that you will find online will probably stop at this point, my goal here is to kind of, like, as said, give you an option or something like a template that you can use as a source of inspiration whenever you need to create maybe a minimal API project, maybe for your customers, or maybe during an interview. And there are some things that we need to be careful about, because when we create minimal APIs, we have just implemented right now regular or very basic CRUD operations on only one resource. The problem is that we have added a lot of code in our program.cs file. And that's for sure not something that looks good. It's for sure not something that's readable. And it will become less and less readable with more resources that you add to your minimal API. So this idea of just mapping endpoints in the program.cs that you see virtually in all the documentations and the tutorials is not something that is really meaningful. It's not something that we will do in real or regular applications that we might want to create with the minimal API. Then again, the same goes also for this other part where we register services. Because yeah, in this case, we just have one repository, we just have one DB context and the mediator. But when you create a real application with several different resources, you might have a bunch of different repositories. You might have a bunch of different other services, like you would like maybe to configure authorization policies or a lot of different things. So probably this part will also get longer and longer and longer. And easily or step by step, this program.cs file will become unmanageable and unreadable. So the challenge is here right now, okay, let's find some ways in which we can refactor this code to be more readable and easier to maintain. So this would mean that we kind of like would have to split these different parts in different, let's say, dedicated classes that are only responsible to perform a certain type of thing. And I would suggest we should start first with finding a way to actually move kind of like these service registrations out of this program.cs file, maybe in a different file, or we'll see exactly how we'll do that. But that also allows us or gives us the option or the freedom to actually, maybe if we want to group adding different services that kind of like belong together and have them all in separate methods or in separate classes even. And the end goal in the end is that what I would like to have here is that I would like to have only one single method that I will call here on the maybe builder, and that will register all the services that kind of like it finds in my minimal API project, or maybe even in other projects. So let's see into a few options in which we could achieve this. The easiest way to proceed here is, from my point of view, to use some extension methods. And therefore, we'll go over here and add a new folder, and we'll call this folder extensions. So this folder is right into our minimal API project. Even maybe here, just rename it and also add an S at the end, because we'll have probably different type of extensions here. And we'll create a new class. So here have add new class. That should do it. And I'll call this class minimal API extensions. And we'll see exactly in a while probably why I want to call this minimal API extensions. Now, the first thing that we want to solve is, of course, for the extensions, we need a class to be static. So we'll make it static, of course. And the first thing, or the first part that I want to resolve and declutter my program.cs file is to actually register the services. So for that, I will create here a static method, public static. It will return void, of course. And I'll call this method just register services. Now, this extension method actually, and that's a very important part, and we'll see just in a few seconds why, is not on the iService collection, because services are usually used in the or are added to the iService collection or on the iService collection. However, in our case, if we just take a look here, we see that in order to add the DB context, we need to also access the configuration to get the connection string. And the configuration, well, is different or is totally separated from the iService collection. Now, this is why we'll have this extension method on this web application builder. And we'll call this builder, like it's called also in the program.cs file. And here we have this one right now. We can just go over here, really cut everything and move everything into our method that we have created here. So this extension method. Now we have some errors here. Okay, a builder. Okay, because this builder web application, that is not something that we should have cut from there. So, and you see, this is a reason why copy pasting code might not be such a good idea. And in this case, I just wanted to, well, have a little bit more time and be more efficient, because this video already probably is a lot longer than I would have expected. Still, here we have this web application builder, and on that builder, we want to actually do all the stuff that we previously were doing directly in the program.cs. And this means in turn that we can come back here and we can just say here builder and here register services. And that's it. Now all the services are moved away and everything should be fine. Now, the idea behind this is, of course, we just have here a bunch of lines of code and just a few bunch of services. But in reality, what you can easily do is actually you can have this public static void method with register services. But then if you have more services that you want to add, that you might be able to group in different logical groups, you can then create private methods for each group. And then in this method, that will only be an orchestrator that you can have register database services, register utilities, register repositories, And you can just call those methods here in this one, and this one will just orchestrate what services exactly need to be added. And in this case, from my point of view, by doing this, the code will become more maintainable and easier to understand, and also, of course, easier to read, therefore. So the first problem is actually solved with the services. That was actually quite easy. Now, the only other problem here is, and I guess we can just also remove from here some stuff. We don't need this anymore. We don't need this using here anymore. It doesn't really do anything. And we also don't need this anymore because everything is moved to the other file. And now comes for the more trickier part, because when it comes to this one, to mapping the endpoints, things are a little bit more difficult. Now, for instance, you can imagine right now we have, for instance, only posts. And we can think of these posts as resources, but when we will have also users, maybe we'll have interactions, maybe we'll have groups or anything else that we could have on a social network. So you can imagine that, or you can see that we can actually group those type of resources or this type of endpoints into groupings of endpoints that in a certain way belong together. And this means that we can also replicate this type of model where grouping different endpoints that belong together in their dedicated classes, it would be a good approach to actually have a sustainable and maintainable and scalable minimal API project. Because just writing everything here will not really help at all. So in order to do that, because there is one other thing, the other thing is that whenever you have kind of like such a new grouping of endpoints, it means that anytime you add a new one, you should make sure that you come here and kind of like call the method that would register all the handlers from that specific grouping of endpoints. Now, this would also be a little bit cumbersome. So what I want to propose you is show you a way that uses a little bit of reflection, but that is really powerful, because when you set up your project this way, you just have to write that thing once, and then no matter how many such groupings of endpoints you add to your application, they will automatically be added and mapped as route handlers, and you can directly use them. So to set everything up, we first of all will need an interface for that. So it means that we'll go over here and we'll create a new folder, and we'll call this folder abstractions. So let's call this abstractions. And in this folder abstractions, I will create an interface that I will call, let's say, what is here, a class, and then I'll choose interface, and I choose to use the naming of endpoint definition, and I see endpoint definition. So endpoint definition. I guess it's correct. The idea is that it means that kind of like we have groupings that define routes. And that's why I see endpoint definition, because it refers to a certain endpoint like the post, but it defines different routes for it. So I call this endpoint definition. However, you don't have to stick to this naming. You can group or name your classes that will group the different route handlers the way you want. You can use modules, you can use some other type of naming. So that's really not important at all. Now, the only thing is that the only thing that we'll define in this interface is here a method that will be register endpoints, and it will pass in the web application, because on the app is the place where we actually register the endpoint. And now the next thing that we can do here is add another folder in the minimal API. So we'll go to add new folder, and we'll call this folder endpoint definitions. And here in this endpoint definitions, you can think about this folder like similar to the folder called controllers in regular ASP.NET Core projects. So here we'll add a new class, and we'll call this class a post endpoint definition, because it's an endpoint definition that refers to my post. So that's the way that I prefer to name things here. And here I would say that I inherit endpoint definition. So endpoint definition, it should be like this, I guess, but maybe I have mistyped something. Generate endpoint definition. Okay, let me go back to the interface, because maybe I have something wrong here. So endpoint, yeah, of course I did this wrong. So let's rename this endpoint definition. something like this. Okay, I want to rename also the interface and everything around that. But also it's still not okay. So let's just rename it once again, because this E should be capitalized. And yeah, right now they didn't do this here. So let's make it like that. And then let's go back to our post endpoint definition, and here and endpoint definition using minimal API abstractions. Cool. So that's exactly what we want to use. And then of course we just need to implement this interface. So we will have this method here. Now, the only thing is that, or the thing that we could do here is right now, we could even go to the program.cs and make sure that we'll take everything that we have here. We'll take really all these routes, because all these routes are kind of like definitions for my post endpoint. And we'll just cut everything from here, and we'll move it to this post endpoint definition in the register endpoints method. And here we have done kind of like this. Cool. And let's see if everything works. Of course, probably we'll have to import here some bunch of usings so that everything is okay. It would be for queries. I guess we need to add for posts, and I guess that that should be kind of like it for now. We just have moved everything away from there. But also this with name I don't like. Let's make it like this. And here I have now all my endpoint definitions. Cool. And then the final step to actually reorganize things and make sure that whenever we add a new class that implements this endpoint definition, it will automatically be added, or that those endpoints will automatically be mapped, so that we don't have to manually map everything or go to the program.cs and call methods to map this for each different endpoint definition. Here is the part where I said that kind of like we could do something very, very nice and neat and use just a little bit of reflection to get things started. So let's go back to this other class, which is the minimal API extensions, and we will do just that. So I have here a code sample or a code snippet that I also use. And let me, I don't know, maybe let's just bring this to another line so that it becomes more clear. And I will explain what we'll do here. But actually, it looks maybe a little bit complicated because it's reflection, but in the end, it's really, really easy to understand. So what we do here is that, of course, what we want to do is we want to scan our assembly where we have the program class, which would be essentially the minimal API assembly. And we want to scan this assembly for types that are assignable or that implement the endpoint definition interface. But, and this is very important, we want to also make sure that we want to only get types that are not abstract and that are not interfaces. Because if we don't add this, it would mean that when we do this for each, it will also take into consideration the interface. And the interface is something that we surely cannot create an instance of. So that's why this condition here is very important, so that those types should not be abstract classes and should not be interfaces. Now, when we have filtered those types, so we have seen, okay, how many types do we have right now in our assembly that implement the endpoint definition interface, is that we make a projection, and for each of them we create an instance. So we virtually create an instance of that specific class. Now, being the fact that the class contains basically or implements this endpoint definition interface, it will also mean that it implements, the register endpoints method, which is kind of like cool. But the only thing that we have to do afterwards is, because by reflection, it doesn't really know exactly that it is an endpoint definition. So we cast it to the interface itself. So what we end up having is that we'll have an enumerable of objects, because they are instantiated, because we use the activator to create instances that implement the endpoint definition interface. And this in turn means that we can loop or iterate through that enumerable. And for each of the objects that we have there, we just hit this register endpoints, and automatically it will be registered. So this means that right now, once we have this method, if I go here to endpoint definitions and I create a new class, like for instance, I don't know, comments endpoint definitions, and if I implement this endpoint definition interface, I don't have to do anything. It will automatically also, or those endpoints will automatically also be mapped because of this for each. And that's a really powerful way to keep everything very, very, very clean. Now, the only thing, of course, that we need to do here is we need on this app to call, how did we call that method? Let me go back here because I really just forgot. I'm pretty old. So register endpoint definition. So let me go back here to this program and yeah, just use this extension method and everything should be cool. Now, to prove you that this actually works, we can just run the application and then head over to Postman and try again at least a bunch of endpoints to just make sure that everything still works correctly. Because at this point, as we have just moved all the definitions or all the endpoint mappings into a different file, if one is working, that it means that all others will still be working very, very fine. So let's have this get all posts and let's hit the send request. And I would expect a 200 OK result that will return me a collection of 2 posts like it did previously. And indeed, so everything works. But right now, basically, if we go back here, we can see that our program.cs class gets much, much cleaner. And having this type of structure into your application actually means that no matter how many services you will still add, no matter how many endpoint definitions you will have, this file or this class will always remain like that. It will never change anymore. So, and it is pretty straightforward. So like what you're doing here, you're registering services. We have an extension methods for that. Then we build the application, we use the HTTPS redirection, and then we register endpoint definitions, and that's it. So everything else happens from this point on into each of the endpoint definition files. So this is a very, very good way to keep your minimal API structure very, very clean and easy to understand, and from my point of view, also very well organized. However, we are not ready yet. There are some things that I don't like about how the code is here. And I would for sure not have or write such code in a production ready app or for a customer. And the first thing that actually I see here that kind of like is a problem, and it was a problem when I was typing all these endpoints, is that we have a lot of, well, apart from our endpoint or from the route, it's very repetitive. So for each endpoint, we have this kind of like base of /API/posts. Now, one very important thing that we have in .NET 7 Minimal API and that we did not have in .NET 6 Minimal API is the ability to actually create route groups. And the way this works, we can say here var posts equals app.map group. And when we say this map group, what we can do here is actually specify that we want to map a group for API/posts. And this will become de facto our base URL address, let's say, for all the endpoints that we have. And what this allows us to do here is that in this case, we can just first of all replace here this with posts. And in that case, we don't need all the stuff anymore. The only thing that we need is the ID. If we go here, once again, we can replace this with posts, because in this map group, we then register or map a post. In this case, actually, this is like this because it's on API posts directly, and it would be okay. Now the get, when we get the list, is exactly the same. So we can just replace here with posts, and it should still work. Of course, we need then to replace this and just say that that's the base URL for the group. This is what we actually want to map. And then for the put, it's exactly the same. So we can simply use this post, and then we can just remove everything from here and just keep the ID, because that ID is what's different in this route right now. And the map delete, we can do exactly the same. So instead of app, we'd have posts with the map delete. So, we can go get rid of this kind of stuff here. Cool. So if I run the application and if I go then over to Postman, I would expect right now to have the exact same result, but right now the route mappings are a little bit more clear and easier to write, taking advantage of this map group feature that we have in .NET 7 Minimal APIs And once again, that we did not have previously in the .NET 6 minimal API. And from my point of view, this is a very neat and useful improvement on what the .NET 6 minimal API actually was. But I am still not happy with the code that I have here. Why I'm not happy? Because right now, okay, we have optimized it a lot, but still we have these lambdas, and all the code that we have is placed into lambdas. And what I would like to have is in the place where I define my route, I want to have it very, very succinct and clearly what are the current routes for that certain endpoint definitions, so that I don't really have to scroll through all the stuff here to actually see what my routes are. So this would mean that what I would like to do is to extract actually all this logic that we have into these lambda expressions into own methods, and then use those methods here basically as route handler. And that would kind of like simplify a lot the way that my code would look like. And yeah, that's kind of like very, very easy to achieve. So let's start with the first one here, which is, yeah, let's copy this code. Which is the map get, and here we actually get by ID. So the first one is the get by ID. Cool. So let me just also make sure that, okay, where is the class? Where does the class end? Here does it end? Cool. So what we'll do here, we'll have here a private, and in this private method, it should then basically return an I result. So that's exactly what we want to do. But as it will be async, it should return a task of iResult. Once again, we are using these results, and iResult basically is implemented by results. Very similar to what the iAction result is, once again, in ASP.NET Core. So we'll have here iResult. This would be a task of iResult, and the name of this method would be get post by ID. Now, the one thing that we have to make sure is that we kind of like keep the parameters that we have in the method. So we need the mediator and we need the int ID. So let's use that. So I mediator. Cool. So this is the mediator. Let's call it mediator, and then int ID. It should be like that. And here we can just paste the code that we previously had in the lambda. Of course, we need to make this async. Cool. So now that's async, everything is okay. However, there is one other thing that I would like to optimize, and I briefly told you about that at a certain point when we were creating endpoints, is that one way that we can return results is just by results okay, but the other way is the typed results. So typed results okay. And of course, I have a typo here, so this is why it's not working. And between results and typed results, there is a big difference, because as the name of this class implies, the results that we kind of like create right now with the post is a typed result of OK of post. And the thing is that previously this was not available in .NET 6, and it made testing minimal API pretty complicated, because every time when you made a request, for instance, you needed to test, okay, is the response 200, then serialize the body to JSON or to an object and see exactly if that object is assignable to a post, and things similar to that. And that was kind of like a little bit cumbersome. But with the typed results, it's easier to test, because you can then make just a request in an HTTP client and expect a typed result of okay of post, and everything should be fine. So the key learning here is that in order to make your application or your minimal API easier to test, just make sure that you always return typed results and not only results. That would be a very, very important part. Cool. But now we have this method, so it means that we can go back up here, and what we can do in this method, we can just keep the name and everything, but we can actually remove everything from here, and we can just get a post by ID. You just specify the name of the method. And since this is a delegate, .NET 7 will make sure that it will inject here in this method all the things that we need, like the mediator and the route param that we have actually for that one. And once again, that's actually very, very easy, or it's more readable than previously. So what we can do here, once again, of course, is we can apply exactly the same principle, a private async task of result. I should once again type correctly, and this is the create post method. And in this create post method, I guess we need the mediator. So we need the mediator. And let's give it also a name to this. And we need a post, which is a post. So this is what we need there. And then the things that we can add here is once again create post. And instead of returning results, we will return typed results like we did earlier. And we created a route, and this one should be okay. Okay, what is the problem right here? Created post with ID. Argument cannot convert from type anonymous type into an int of string. Okay. So the problem here is with the type results is that, yeah, now probably here in this case, we just need to use still the results, and then everything should be okay. Now, if we go back to this create that we have, it means that we can get rid actually of everything that we have here, and instead replace it with this create post. And yeah, now everything should be fine. Okay, then we can do exactly the same thing also for this other map get. In this case, we just need the mediator. So let's go here and let's create a private async task of result. And what was a get all posts. So that's what we can do here. And yeah, here we just need the mediator, mediator, and then we can just move here the text and also change this to a typed result. And it should be okay. Now what we can do is, of course, get into this method. And once again, we can virtually delete everything here and get all posts. Cool. So now we have this one. Now we have this update. And for the update, we need the mediator, we need the post, and we need the ID. So we'll keep this in mind. Let's just also create this method, the private async task of result. Okay, and update post. Cool. So what did we say that we actually need here? Actually, we'll just copy this and paste this over, and we'll know. So first of all, we'll need the mediator. Then we'll need the post, and then we'll need the int ID. And we are good to go with this method right now. So we can just come back here to this one and just delete everything and replace it with update post. It would be this one. So that's okay. And last but not least, we have this delete. And in this delete, we need the mediator and the ID. So let's also go here and create a private async task of result like we did earlier. And here delete post. So here, but here we'll also change this to be a typed results like we did also previously. And here we have delete post. So mediator, that's what we need, the mediator, and we need the int ID. And then we can just paste everything here, change these results into typed results. And then basically we can go over here, and once again, we can delete everything from here and replace it with the, okay, but we still need the parentheses. So delete post. That would be the one with which we replace. And as you see right now, basically when I go into my method, I can even, well, make this or optimize the space between. And what this refactoring allows me to do is that right now, when I come to an endpoint definition class, I can already see, okay, these are my endpoints. Because I'm not interested, I just want to have an overview. Okay, those are the endpoints. Then if I want to go for the implementation of the method and the logic and how it's implemented, we can, well, simply jump over and go to it. But we have one place in which we can see virtually all the endpoints that we have mapped for that specific endpoint definition. And that already is very, very important. Now let's prove that this still works by running the application and trying to make another request. But I am fairly confident that things will still work just fine and that we will not have any problems. So let me just hit the send. Okay, so it seems that we had a problem. Okay, what did we do here? API /post error. Okay, something with the connection is not okay. Let me check, is the application running? So yeah, it seems that the application is running correctly. Let me, I don't know, maybe just try again. Maybe the application was not started yet when I ran the request. So yeah, hopefully this time it will work. But I think it should work, because every time it's the first time that it makes a call to database, it takes longer, but we proved that it works. So we have actually refactored right now our endpoint definition so that it looks, first of all, easier to read. It is easier to maintain because you can go in each method and just update that specific method. You can have a look at all the mapped routes just in a single place. You don't have to scroll around. And we have improved by using typed results so that we have made right now our endpoints easier to test, which is actually very, very, very great. However, there are still two more things that I would like to include here in this full course on the .NET 7 minimal API with clean architecture, EF core, repository pattern, CQRS and MediatR. And that is, okay, we have some endpoints, for instance, for the create and for the update, where we kind of like get a post from the body. Now, one thing that we want to do is we want to do model validation. And I really want to go into this topic because in ASP.NET Core, in the controllers, like the regular APIs, we have that model state. And we can easily decorate, for instance, our post with different attributes in which we specify exactly some rules for validation. And then we can simply use the model state to check if the model state is valid or not. Now, one thing with the minimal API is that it doesn't have a model state. So this means that we will have to handle the validation by ourselves. Now, that's not necessarily too complicated because we could even use libraries like Fluent Validation to achieve that. But in this video, I just want to show you what's the best way to actually perform validation in .NET 7 minimal APIs with a very, very minimum validation that we will add ourselves. But of course, you can extend that to use Fluent Validation and then, well, create your validators or your abstract validators to define exactly what and how do you want to validate. Now, one other thing that's important and that was not previously there in .NET 6, and for me, that's why the .NET 6 minimal APIs were a no-go, is that it didn't have, or it didn't have support for filters. And that's a big problem because usually when you think about validation, you think about filters. Now, filters in ASP.NET Core as a concept is just a way to perform some actions right before an action is executed and right after the action is executed. That's why filters are useful, and that's why validation is usually done in the filter. Now, this means that in .NET 7, as said, we have now support for filters. Now, the filters in .NET 7 minimal API are surely different than the filters that we have in regular ASP.NET Core applications, because in ASP.NET Core, like the regular controller-based approach, we have different types of filters that kind of like have a different purpose. We have a filter pipeline that also depends by type, by the way that you register it. In .NET 7 minimal API, it's well, a little bit more straightforward for now, and the filters are actually called endpoint filters. Now, what I would like to do here is simply add a new validator as a filter, as a .NET 7 minimal API filter. So for this one, I'll add a new folder and I'll call this folder filters. And in this filters folder, I will add a new class that I will call post validation filter. So post validation filter. That's how I call this one. Now, to make your class being a filter, the only thing that you will need to do is to inherit implement, not inherit because it's an interface. So endpoint filter. And of course, when we want to inherit an interface, well, that means that we will probably also have to implement some bunch of stuff. And that's actually the implementation of a filter in what we have here. So we have here a value task with invoke async. That's the method. And I have a code snippet here that I have already prepared. So I'll just use it and we will go through this once again. So of course, this needs to be made also async because that's, well, of course, an async thing. Now, good. What we can do here, and here the post content, what's the problem with this? Indicates, okay, there is no argument given that corresponds to the required parameter value of string is null or empty. Okay, cool. We'll just look into that. Now, the problem here is, or what we actually want to do here is, first of all, we want to, well, validate our post. Now, in the minimal API, what it happens is that when a request comes in, basically in this endpoint filter invocation context, we have a collection of arguments, like the arguments that were passed in either through route params or to the body, all the arguments actually that are passed into our route handler, including services that are injected from the dependency injection container. And this is why when we want to get a certain argument, because we want to only validate the post, we need actually to say, okay, we want to validate the second argument and as a post. So this is why this is a generic. But then it's also important to go to the definition. Here is the place why I said it's important that here, when we have this create, the post should be at the second place. And for the update, it should always be at the second place, because then in our filter, what we can do here is we can say get arguments of 1. As all collections, it's 0 index. So it means that the first element will be, or the first argument will be on index 0, and the second argument will be on index 1. And this in turn means that, yeah, in this case, we will always be sure that we'll always validate this filter or this or the post. Now we have created the filter. Now the only other thing that we need to do is kind of like say to the specific endpoint that, hey, for this endpoint also please use this filter to actually validate our post. So if we go back to this post endpoint definition, here, first of all, we need to go to this create post. Not here, but where we did the mapping. So this is the create post. And like we had this with name, which was a metadata information for that specific route, what we can do here is we can say require endpoint. How was that method called? Let me just check. It was required, but I don't recall exactly. Add endpoint filter, not require, sorry. So yes, it was add endpoint filter, and this is a generic method in which we say that, hey, we want to add a filter which is of type post validation filter. And yeah, that means that we have added our filter to this specific method. And of course, we can then just take this from here, and what we can do, we can just paste or copy this, of course, and also paste this for the update, because this is also the point where we actually want to validate something. Cool. And let's now prove that it actually works. But what we want to do, let's go back to the filter, because I think I want to do this a little bit differently. Okay, so it await task from result. The idea is that if the content is null or empty, so if we provide an empty string in a body, we just return a task which is a result bad request. So we just create a bad request. Cool. In that case, let me just validate here. So yeah, let me just run this application and let me show you how that filter works. So remember, we can validate, or we can see if everything, okay, we have some build errors. Okay, no, we don't want to run. Where are my build errors? Okay, cool. I don't see any build errors. Let me rebuild the solution in this case, and then pinpoint exactly where the problems are. Okay, so the problem was actually that the content was, well, a nullable string, and then we should have called this string is null or empty on the post content. So sorry for that. Okay, Cool. So now we have a working project once again, and we can just run it and test once again the validator out. And let me just wait a little bit until it starts. And I want to emphasize once again that the validation is done on the create and here on the update. So we can just use the create, and here in the create body, in order for the filter to actually kick in and return a bad request, we can just pass in an empty string. So in this case, when we run this request, we see that here, okay, we received this 400 bad request, post is not valid. So exactly what we have actually written here in this result. We can maybe just, I don't know, move this return so that it's visible. So it's exactly what we have defined here is what it was actually returned. So we have proved that actually the validation works in this case. Now, before we wrap up, is there actually one other thing that I would like to show you? Because one thing that I can really here reproduce very, very easy is a scenario where we get exceptions, because surely in your minimal API, you will also get exceptions. That happens. Now, if I have changed here this argument from 1 to 0, I know that the first argument is the iMediator and it is not the post. And I would expect that in this case, actually, when I run this application and when I try to create, for instance, a new post, I would expect here to receive an exception. And actually, well, as it happens when exceptions are thrown, that's really not beautiful at all. So let's do this and let's wait for the request. And indeed, we see that we have here this invalid cast exception because we wanted to cast the mediator to a post. And of course, that was not possible. So we got an exception. The question then arises, what do we do with exceptions in minimal APIs? Now, just a short reminder, when we talk about regular APIs where we have controllers, there are virtually two ways to catch these exceptions globally. There is one way to use exception filters for that, and there is the other way to use like a middleware. And I have created a video specifically on that topic, showing exactly what is the difference between when you use exception filters and when you use middleware. However, here in minimal API, we don't really have an exception filter. So it means that kind of like we need to use a middleware for that. Now, where to put this middleware? Of course, like we do in regular ASP.NET Core applications, here is where we actually configure our middleware pipeline. And the exception filter should actually be the first in the pipeline because it would also be the last through which actually a request goes through when something happens. And I will paste here this code for a very, very basic middleware, which it's basic, but it is a global exception handling middleware like app.use, and we have the context and the next. What we do here is we put this awaits next in a try block. It means that if anywhere down the line it will throw an error on an exception, we will catch it here. And once we catch it, well, we set the status code to 500 and we write the response, which will actually then create this 500 response and send it back to the consumer. And this kind of like changes dramatically because right now no exception will be thrown, but the consumer will be kind of like notified in a very regular and standard REST way that, hey, we had an exception. And here, if I run the application again, and if I will do the exact same post request once again, that I know for sure it will kind of like cause trouble and create an exception condition, I will see that the result will be totally different because in this case, let's just wait for a bit. We just have a 500 internal server error and an error occurred. Either way, in this case, actually, it's not really a server error because, it is a server error in the end because we didn't map things correctly. So it's not a client error. So we are okay to send a 500 request, but you notice the difference now instead of just throwing an exception. And well, then the exception was then received by Postman, and Postman knows how to actually handle that. But you can assume if there is a front end that consumes this and it receives kind of like, hey, there's an exception, it wouldn't really know exactly what to do with that because it would expect something in JSON format or at least something that's formatted in a certain way. And that's what we actually want to do with this global exception handling middleware that we have here. And of course, you could even format or write as a JSON here. Maybe you can create an error object and you can create a toString method that kind of like creates a JSON representation. of that object, and here in this write async that you can then call that object with the toString, and it will result in a nicely formatted JSON. But for the purpose of this kind of like short tutorial, or actually it was not that short, but it was in depth because it covered really all the areas that you need to be careful about and that you need to be aware about of when you start to really work on a real project with the .NET 7 Minimal API. So yeah, the idea is that we have right now, I guess we have covered everything that I wanted to do here. And before we wrap up, I just want to make a brief summary of what we have discussed during this short course. Because we have started really from the very beginning. We wanted to create a .NET 7 Minimal API with clean architecture, with exact folder structure, with database, using Entity Framework Core, also using the repository pattern, and also using CQRS with MediatR. So that was the purpose of what we wanted to do. And therefore, we started right from scratch when we have modeled our project structure according to the clean architectural principles. And we have defined our layers like the domain, the data access, the application layer, and the minimal API itself. Then we went one step further. We have defined our domain model, which was a very simple post. Then we have implemented the data access layer. We have seen how we implemented the repository pattern and how everything fits together when we work with this kind of like minimal API. Because when we are creating migrations and updating the database, starting project or the startup project for the migrations and for updating the database is the minimal API project. So we have seen how we have set that up. And then we went over to implement the application layer, where we have used kind of like a CQRS approach using the MediatR library. So we have defined our applications in, we have subdivided actions that might occur in our applications between queries and commands. And for each of them, we have dedicated handlers that would handle that specific query or that specific command. And then for the most part of this course, we have concentrated on the minimal API itself. And we have actually taken a very, I would say, pedagogical approach. We have started from what everybody does usually in demos and in documentations. We have placed everything in our program.cs. And then we have step-by-step, or we have looked step-by-step for ways in which can improve our code base, so that in the end, we wanted to end up with kind of like a template that you can take when you create a minimal API project that's clean, that's readable, that's easier to test, and that's also easy to maintain. And we have refactored all that we have written towards this kind of goal and scope to make everything as clean as possible. And for that, we have used filters for validation. We have implemented also middleware. We have implemented extension methods that kind of like register services. We have implemented an extension method on the web application that automatically scans the entire assembly for endpoint definitions and automatically registers the routes, so that we have to set this up only once when we start the project. And then no matter how many classes you add that inherit from that endpoint definition interface, everything will be automatically added as a route when the application starts up. So that's kind of like a very, very powerful thing, and I would strongly advise you to actually do that. Now, probably you will hear a lot of people say, hey, but you're using reflection, and reflection causes performance problems. And yes, that's true, but you only run that reflection code once and start up. So when you're starting up the application, to be honest, I am not really concerned about the performance. Of course, if it would take 10 minutes for the application to start up, then I would be concerned, or even 1 minute, but it still starts up very, very fast, and you only have to perform this once. So the downside is that there is a performance cost, but the upside of this is that, hey, everything will be automatically, or all your routes will be automatically mapped, no matter how many endpoint definitions you have. And this kind of like brings a very, very healthy plus to the equation. And I would therefore recommend to go for this approach, because it's really, really powerful. This being said, Thank you very much for the patience that you had for watching this entire video. I hope it was helpful for you, and I really hope that it provides you with a good foundation and kind of like a template and structure whenever you need to create a new minimal API project. That's kind of like a template to use for your real applications, for customers, for interviews. You can just look to that and you can customize it further with all endpoint definitions that we need, with filters that you might need to add also, and with other middleware if you might need to add middleware, and a lot of other commands and queries and handlers. But that's really, you have the baseline from this here, or from this point on you can really build upon this and kind of like create any type of application that you might need with this .NET 7 minimal API. If you think that this content was useful for you, don't be shy and hit the thumbs up button for this video. Also subscribe to the Code Wrinkles channel if you didn't do this already, and also hit the notification bell to make sure that you are notified whenever we have new content here on this channel. And also, if you think that there might be other people that would find this content useful, don't be shy and share the content with your peers, with your colleagues, with whoever you think that might be interested, maybe at work, in your social media, on forums, wherever you think there is somebody that might find this useful. Please do that, and probably that person would be thankful to you. This being said, once again, thank you very much for watching, and until the next time, I wish you the very best.